we get to that, I thought it's a great opportunity to tell you a little bit about the JGI and go through a couple of housekeeping things. So could you go back, Sandeep, a bit in your presentation, if that's possible?
Yep, sorry, it just kind of went.
That's okay. So if we go to the, Sandeep's in charge of all the slides this morning.
Yep, I am. I think it was just flipping in reverse. So yeah, can you see this one?
Hasn't changed for me. Is it changed for you, Lily?
No, that hasn't changed. It's still on the showcase slide.
Okay.
Okay, well, don't worry then. I can talk without the slides. It's fine. But it'd be good if you could try moving it on. Okay, now that is important. Yeah, okay, that's moving
there
now. Great.
Okay. So what I had done was I was trying to present in full screen and.
Okay.
Yeah.
Yeah, okay.
Well, I guess it will have to be like this, so that's fine. Sorry.
That works fine. So first of all, to say that we are recording today, that it would be great if you could have a look at our code of contact for online events. And if you haven't had a chance, Lily will put a link to that in the chat. Could you fill out the registration and feedback form? It's really great to know what you've enjoyed and what kind of events you might like to see in the future. That'd be fantastic. We'd like to take questions using Slido today. It makes it easier for us to collate questions so that I can present them at the end in our Q&A session. So this slide you're seeing now gives the details of the Slido account, and we're also going to put a copy of that in the chat as well. So if you want to move on, Sandeep. That's brilliant. So many of you will already be friends of the Jean Golding Institute, but for those of you who aren't, welcome. It's great to see new people in the audience. We're here to serve the communities of data science and data intensive research and AI. We're one of 5 University of Bristol research institutes. We're constituted outside of the structure of faculties, so we have a lot of independence. But we all share a remit to generate and support multidisciplinary research communities around our topics. You can see from the little infographic here that we have 4 main strategic priority areas within the Institute, and those are societal challenges, data visualization, realization, materialization, reproducibility and data governance. So that includes the kind of open data frameworks as well as conversations around ethics and consent. And fundamental or foundational research, which at Bristol is largely focused on the mathematics, statistics, and computer science communities within the university. And we support those strategic priorities with these 4 cross-cutting mechanisms. So first of all, events around developing communities. So this is a good example of that. We also provide seed corn funding for new projects. We work with PhD students through competitions. We host data competitions, those kinds of things. We do training throughout the year. Obviously, you've seen that we have lots of training opportunities this week in Data Week, but in fact, we offer training in different ways and bespoke ways throughout the year. So keep an eye on our website for information about that. We're also the portal for the University of Bristol's relationship with the Alan Turing Institute, which is the National Institute for Data Science and AI. So if you're interested in the work of the Turing or ways in which you can get involved, do let me know. And we offer a data science surgery service in a sense. So we call that Ask JGI. So anybody researching in data science can email us, contact us through Slack, and we can talk to you about your data science query and point you in the right direction. Next slide, please, Sandeep. And again. There we go. So you've all registered. You've probably seen a version of this calendar, but we're now on Wednesday of our 5 days of Data Week. We've got 40 events over those 5 days, and you can see on the calendar the kind of spread of those. We've tried to include topics which engage with all parts of the data science pipeline, from data generation all the way through to analytics and data communication. And you can see that very roughly color-coded, we've got lectures here in yellow and training in blue, and networking events in green. So if there is something that interests you, please do come along. I'd like to flag our lunchtime networking sessions that we've got working in Remo. We had our first one on Tuesday. It worked very well, so do come along to the next one, and you'll get to meet a few people and take the opportunity to do some networking as part of this event. Next slide, please. And we'd like to give a shout out to all our partners. You can see LV General Insurance in there, but we'd like to thank everybody that's taken part in this, who's worked with us to co-produce events in this Data Science Week. We wouldn't be able to do it without you, and you provide that kind of richness and diversity of community that we need to do the very best data science. Next slide, please. Do stay in touch with us. There are a number of ways of doing that. You could join one of our clubs like Data Ethics Club or the Data Visualization Working Group. You could subscribe to us on Twitter. You could read our blogs on the website or even contribute a blog. We'd be very welcome to have you. And if this event of Data Week has kind of piqued your interest in the work of the Institute, then I've got something else for your diary to put a hold in. Next slide, please. Which is the Showcase 2022. This was postponed because of the pandemic, but we can now confirm that the face-to-face events will be happening at the M Shed, which is an industrial museum in the centre of Bristol on the harbour side, walkable distance from the train station. But it'll be a blended event. There'll be online activities too. So it's going to be 2 days of a celebration of all things data science within the university's city and region, engaging with local communities, engaging with local schools, showcasing research. And it's going to be a really lovely, I hope, really lovely celebration of the work that we do in the university and the city. So with no further ado, I'd like to introduce our speaker for this morning. So Sandeep has contributed twice before to Data Week events, so it's lovely to welcome him back. He's a data science manager at LV General Insurance with a background in engineering and analytics, has extensive experience across a number of domains, including insurance, banking, telecommunications, pharma and consulting in 5 countries. And at LV, he is working on successful implementation of ML learning models across claims, marketing, pricing and fraud, and a whole host of other areas. And so it's an enormous pleasure to welcome you again, Sandeep, to give us some harsh realities of being a data scientist. Over to you.
Thank you. A very good afternoon to you all. I'm hoping you can hear me. Okay, thank you for the great intro about JGI. I'm Sandeep Karkhanis. I'm quite chuffed here, quite chuffed about being here today. And in my talk today, I hope to share some realities of the data science world and hopefully bust a few myths along the way. Importantly, share a few secrets on how we managed to build a successful data science team at Liverpool Victoria General Insurance Group, which we just kind of say as LV gig or LV, just to keep it simple. This is how I look. Kate's given a little bit of an introduction about me. So at LV, I have the great pleasure to work with an awesome team on applying data science across quite a few different areas. And I'm also part of the Data Science Council, which works towards strategic growth and supporting team. And I'm also quite passionate about data science for social good. And I do have a life outside the data science world. And I love traveling, scuba diving, cycling, just to kind of name a few things. Unfortunately, because I'm presenting from my Mac Mini, that only has audio and no webcam. So you'll have to just keep my picture in your head and just imagine me talking. So kind of just the agenda for today. Give you a little bit of an introduction about LV, wanting to share some of the experiences that I've had over the last 5-6 years working in this realm, and how you can go from a proof of concept stage to actually delivering value for a company. So sorry, I'm just kind of getting used to the flipping in a reverse way, but let's get started. So introduction. So who essentially is the, or what essentially is the LV General Insurance Group? So we're a team of about 4,000 people and have about 7 million customers in the UK. Our vision is to be Britain's best loved insurer with the purpose to help you look after what you love. At LV, data science is a strategic priority, which is supported by all. And we believe in applying data science in practice and not just keeping things in theory. Why data science, if you ask? So we've been now almost 3.5-4 years, I should say, as a part of the company. In that time, we've identified, evaluated, built, and implemented about 70 use cases so far. And just last year, we influenced about 20+ decisions made at LV. Typically, our ideation to implementation cycle tends to be 3 to 6 months. Sometimes it's a bit longer in case if things are too complicated. And our goal for 2021 is to have about 20 to 25 decisions influenced within Navi, which is quite a big challenge. And all of these individual decisions compound over time. So that's one of the reasons like you can scale up by doing stuff. Where is it that we focus our effort? Basically, it's to set up for long-term success, and finding the sweet spot between innovation, technical excellence, and delivery. And we do this by collaborating for success. A few of our people in the team are working on their PhDs in data science. We've co-developed a master's in data science program together with the University of Bristol. And as you might be aware, that within the data science world, we use a lot of the work that is done is with open source tools. And as a way of giving back to the community, we have planned to open source at least 3 packages for this year, just to contribute back. And we also sponsor Data Science Festival. Then last month, a couple of my colleagues gave a great talk on the model monitoring. So feel free to check out this link when you have the slides. And I think it is recorded, so you should be able to listen to it. And last but not the least, amongst the other things that we do, we also participate with the Alan Turing Institute on Data for Good initiative. So this is how we just work and find work towards long-term success. So just kind of moving on to the next section, which is sharing my experiences from the world of data science. Before we do that, I just wanted to kind of you guys to imagine, close your eyes and see what do you think about data scientists that actually do. Probably it could be something along the lines of having a MacBook open, modeling with the latest and coolest algorithm. Perhaps heck, it's even a deep learning model. They've built a model, and because of that model, they help decide the next steps of the company. The data scientists present their findings to the exec, and everybody is extremely impressed, and it revolutionizes the business. A meaningful answer, as I call it, would probably be something along the lines of, but in reality, even this is not really close to the truth, because there's quite a few myths around the data science world. And I'll kind of explore them as I go through the talk. Artificial intelligence, machine learning, data science are 3 of the biggest buzzwords in the recent years that are sparingly and quite interchangeably used everywhere. The explosion of data has meant that companies are overwhelmed and looking to it for solutions. So what exactly is data science? Data science is a multidisciplinary blend of machine learning, computer science, domain knowledge that's designed to solve complex problems and possibly even create some new products. Many situations involving data science observations can largely be solved using data science. This is what makes it such a crucial business tool. And it's also influencing the way people interact and make decisions, and thus it has impacts various aspects of our life. Another myth within the data science world is that you must know it all. This largely is aimed towards data scientists. And many companies and people are of the opinion that in order to become a data scientist, you probably need to have a PhD. Personally, I find that it's not mandatory. And because data science is about using data to enable better decision-making, it can possibly even automate repetitive tasks. And ultimately, these decisions are about either saving money or making money or enhancing the process efficiency in some form or the other. So you need to understand that data science is not proprietary to some limited disciplines. And I look at it as something that sits at the intersection of multiple disciplines, such as statistics, computer science, modeling, visualization, domain knowledge, and so on. While a PhD may help to get a good start, I've always found that cross-disciplinary experts, as a result of their past experiences, bring with them an advantage of lateral thinking through different areas and thinking outside the box and essentially add value. Having said that, The data science team at LV is a very good mix of people from very different backgrounds and experiences, PhDs, masters, and everything in between, which is, I believe, one of its key strengths. Personally, for me, skill matters over natural talent and not necessarily degrees or certificates. There was and is a trend a few years ago for the expectation for data scientists by companies that you should, know Spark, Python, Scala, TensorFlow, deep learning graphs, and anything and everything that you can imagine. And all of these with a few years of experience, and that too for a grad position. A few years ago, I remember seeing this job description where junior data scientists were expected to have Spark knowledge with 5 years of experience. This at a time when Spark itself was around 5 years old. So if you ever see such a job description with all of these written over it, basically just stay well clear of it. It basically reeks of a company that has no idea what their data strategy is, and they think that hiring a unicorn will kind of fix all of their problems. And it doesn't just stop here, because the implicit assumption is that because you know it all and obviously have access to all of the data, you're expected to have all of the answers. Well, they should have been done yesterday. And although data science, as we know it now, previously probably went by data mining or advanced analytics, the exponential growth in technology in recent years, be it either for storing, processing billions of rows and newer algorithms, and the sheer variety of data has meant that there is a lot that one can learn and explore. So even if the data scientist has, for example, the right attitude to learn, to explore, and to excel in the data science, that doesn't take away from the unrealistic expectations that companies expect people entering the field to possess. Another common myth is that about 60 to 80% of the time spent by data scientists is spent on cleaning data. Personally, I find this number a little bit disputed, because the IBM page that quotes this links to a Harvard Business Review post from 2018, which links to a Crowdflower report from 2016. So you see what I'm kind of getting at. And obviously, you can arbitrarily label some of the tasks that data scientists do as cleaning or analysis and make them add up to 80%. But I find that it's a bit of a misnomer. Often as a data scientist, you're probably going to receive dirty data that is kind of messy, beyond explanation. You will need to track down 4 different people to explain parts of it. And obviously, there's no real data dictionary to cross-reference any of it. Another common perception is data science is all about building models. As a matter of fact, data science is much more than building models, and there are multiple phases, such as cleaning data, collection, exploratory analysis, visualizing it. Then you need to build a model, and it's only a single aspect of the project. Along with it, you need a lot of different skills on problem solving, logic, reasoning, and storytelling. What I've found from personal experience is that one needs to think really hard, what problem is the business really trying to solve? And for an individual to go beyond the tools and master the skills that would help them to uncover that. Next is the compliance and ethics element. So of course, depending on the part of the world you're in, compliance may be a thing that you need to follow. You'll also need to consider the ethics and bias element into your model to eliminate possibilities of serious errors. Factors such as gender, ethnicity, or proxies thereof are important elements to exclude while preparing your data for modeling. The science in data science. For me, the science element in data science shouldn't just be limited to the algorithms or packages, but also incorporate one of the core tenets of science, which is to experiment, to fail, to learn, and repeat. And it applies not just to the data scientists, but also the companies they work in, to embed it into their philosophy. The art aspect of data science for me shines from the creative thinking to tackle a problem and devising a solution, so you can be more confident in the decision that you're making. Next is the competition platforms. Data scientists are also expected to compete in various competitions, and many of them equate this to reality. For me, platforms such as Kaggle are great. You get a defined problem, variety of problems, data, metric, the community element to learn from Kaggle masters, and it of course looks good on your CV. But in my experience, the reality is quite different, because to solve a problem, when you're given what to solve, is relatively easy. But when you're on the job, talking to different subject matter experts, stakeholders, trying to figure out what the problem is can be a big challenge in itself. Often, you will have to contrast this with the data that you have available to answer the question, gauge its reliability, and also figure out where it resides, get permissions for it, what metrics to use. And all of these things matter. Suddenly, the idea of using a new and cool deep learning approach with images or what have you becomes something that's far on the horizon. Frankly, I'm not against such platforms, but you might benefit from broadening your horizons by looking beyond them. From my own personal experience, by working with charities and other institutions to build a model, you get to see the reality of day-to-day workings, the challenges they face, and you still have to come up with a way to solve the problem. These days, or in the last couple of years, there's a lot of platforms such as DataKind or Driven Data, Operations Research Society, and even JGI that kind of will host hackathons or competitions, which give you a different experience. So what I think is that one needs to think beyond the common platforms to broaden their horizons and understanding. And this kind of leads me nicely onto the next bit, which is some of the reasons why companies struggle with the adoption of data science. And I can start that with a cold start problem. To do data science, you need data. Any company, either a startup or a large enterprise who wants to take advantage of data science needs to ensure that they actually have useful data to start with. And depending on the industry or the business you're in, the right type of data can be in a variety of forms. And on top of that, just having the right data isn't sufficient. And even though artificial intelligence or data science is what currently everybody talks about, before we get there, we have to take an intermediate step, which we can call as analytics for lack of a better word. And what I mean by that is the systematic analysis of data. And companies need to determine what the KPIs are, which actually drive the business. And from those KPIs, a company can then decide what type of reporting or dashboards are necessary for the business to make informed decisions, or even to find out where the pain points are. And another element of this is that companies often tend to be caught up between the hype cycle and snake oil software salesmen. So the rapid waves of technology has caused many companies to be a little clueless with regards to what they should focus on. There's a variety of tools out there, cloud platforms, vendors offering data science and data engineering solution, and that has not made it easy for companies. At the same time, this tug of war between a CTO and a CFO, one wanting the best technology and the other wanting to reduce costs, can lead to indecision, which often leads to no decision. At the same time, you'll have stakeholders that come asking to you for the latest thing that they heard of, or a data science tool that they saw somewhere at a conference that would build a model in a matter of minutes and make data science easy peasy. Here, the startups tend to have it a bit easier because there's no history and nobody in the company that needs to be convinced that it is necessary. So it's likely that from the start they have the right mindset, and this may lead to a better business or product or service. Large corporations or mid-sized ones have a bigger challenge ahead of them, that they will have many layers of management, and a lot of them will not so be easily convinced. Data is often hidden away in silos, and that doesn't help. And with any project, ensuring that everybody or almost everybody is on board is a crucial factor in succeeding. Another aspect that we see is that often with data science, that the lack of evidence that it can have an impact leads a lot of people to believe that it's just a hype and will eventually go away. Because of the stage that data science currently is in many companies, scenarios such as not getting buy-in from management, they're having resistance to collect data or to analyze it, or treating the data scientist as some sort of magician are all too common. Then there is company politics. Funny enough, knowing lots of machine learning algorithms will not make you the most valuable data scientist. The truth is, people in the business with the most influence will need to have a good perception of you. That may mean that at least at the start of your data science journey, you will constantly have to do ad hoc work for the key stakeholders, probably do some analysis projects, just so the right people have the right opinion of you. As I covered earlier with the myth of the 80% time that is spent, reality is a lot of time is actually spent convincing people, ducking attacks, and following up with execs to get their buy-in. A lot of companies that may say that they have a data-driven culture, and by that I mean they think they have some Power BI reports in place, but that's not necessarily what being data-driven is. Tools don't make anything by themselves. They are a means to an end, and often culture comes from people and not not tools. And it's often deeply embedded in our minds, and people have biases, and you as a data scientist going there and waving your magic wand are coming to disrupt all of this. So even though we live in a world where where AI or machine learning is hyped kind of beyond explanation, it takes a lot of effort to bring everybody on board. And even if a lot of the execs, for example, believe that the Facebook, Apple, Google, Amazon kind of route is the way to go, there's much to be desired when it comes to its actual application. A prevailing belief is that you can probably hire a unicorn data scientist and they'll start churning models left, right, center, and there you have success. It used to surprise me, frankly, before, but less so now with the fact that a lot of businesses and functions suddenly say they want to become machine learning driven, don't, for example, collect data, let alone the right data, or have the MI or KPIs in place, which would serve as some sort of a base to identify which areas could be improved. A key point to note here is to think about the actions that they've been taking and their impact. And if these actions don't make any difference, why do it? Unfortunately, this can bring into question the very existence of their jobs. And frankly, if you never have any data or MI, means nobody can challenge if what you've been doing is of any value. The next element is on the reality and where the expectations don't really match. So I touched upon the 80% time spent conundrum earlier. And what the data scientists actually wanted to do was to work on machine learning when they joined. Instead, now they spend most of the time begging for data to be created, accessed, moved, or explained. And the other 20% probably finding friendly tools, security policies, infrastructure, or even looking for a new job. And if you can't use or don't have the right data, as the adage goes, garbage in and garbage out. This often leads to stakeholders to get frustrated too, because they have their own priorities. And this supposed unicorn data scientist who kind of sits around, does nothing useful, and still manages to constantly complain about the data not being good enough, leads the stakeholders to believe that data science is just another hype. Then is the human bias element, which I find quite a bit interesting. Humans being what they are and often resistant to change, you may find that even after building a good machine learning model that's delivering value, that model may not be used or be turned off just because the stakeholder thinks that it's not the way we've done things. We always relied on our gut feeling to make a decision, or the model is used in a way it was not supposed to. So basically, it will be your job to find a way to convince such stakeholders and make sure that the model is used correctly and consistently. I think this last point on here is a key one, which are the productionization challenges. And there's quite a few different elements within this. So there's data silos, there's barriers to accessing data out of key systems, and the politics elements that I touched upon before. All of these only exacerbate the problem of putting models into production. To move the focus a little bit more inwards, it's not just about these problems. Data scientists themselves have to skill up. Working on Jupyter notebooks when developing is one thing. Writing good production code, which is well commented, rigorously tested, version controlled, and portable, is a different thing altogether. And all of this takes time to get into the rhythm of. And even if a model was trained, deployed, and put into production, you'd be surprised how often the data values change or new values are added, which means the code needs to be able to handle the change or raise appropriate exceptions. Next, a dimension within this is the data protection. Lest I forget that. So data protection and LV is the responsibility of everyone working with data to make sure that data is kept safe and that we are following the law with regards to data protection. For every model that we build, it has to complete a data protection and impact assessment, also known as the DPIA, which must be approved by the data protection officer in the company. If you think backpropagation math was fun, try filling out a DPIA. What the DPIA essentially does, it gives the GDPR team the opportunity to review and raise concerns early on while they can still be mitigated. They must sign the DPI before the model actually goes live and can recommend that the project doesn't go into production if they have concerns. All this does is have the checks and balances in place to make sure that everything's okay. Apart from that, you'll also need to have data retention policies in place. And these policies will typically describe, for example, how long the data should be kept, or it should be deleted or anonymized. And lastly, a key challenge within the productionization is key system integration. What I mean by that is typically machine learning models tend to be integrated into key business systems to leverage the true benefit of augmented decision making. For this, a lot of testing in the form of security testing, acceptance tests, reconciliation testing, service readiness, to name just a few, must happen before the model can actually go live. This means there has to be a sync between when the model can be integrated into the release tracks of those key systems. Therefore, a truly cross-functional truly cross-functional team must be in place to ensure that the models make it into production. And this could be data scientists, engineers, DevOps specialists, product owners, business analysts, developers, epic managers, and any other roles that's important for its success. And it doesn't just stop there. When the model is actually gone into live, you typically probably will need to have a backup in place, some kind of model monitoring to gauge the model drift, and MI dashboards to track the development. And all of the above together actually makes what the adoption of data science into a company or into production a success. So these will be some of the things that you'll come across or have seen that where companies struggle with. So now moving on to the interesting bit probably of moving from POC to delivering value. So to make an impact, how is it that we think about data science? To make an impact with data, we combine machine learning, data, and domain knowledge. And I can actually say that with our implementation of use cases, we've managed to put machine learning at the heart of decision making. And moving on to the bit which perhaps you're the most interested in as to how is it that we did it. Starting with your first success. Adopting the data science mindset can have a big impact on the rest of the organization. Some learnings that I can share with you is that building our first couple of successes helped to spread the word and bring in more work. And by capitalizing on these initial successes, we developed a portfolio of use cases that helped us to go from strength to strength. So even if your initial models deliver small incremental gains, that's fine. We found that finding friendly stakeholders and working with them helps. And so does communicating everything that you do to as many people as possible at every level. Probably at the start of your data science journey, you may have to be there at every meeting, conferences, even if they may not be the most interesting ones, to just listen in and get a feel for what's happening. And at the same time, don't be afraid to speak up when someone says something that doesn't make sense, but be nice and explain everything to everyone and help everyone. Finding someone that can be that Captain America's shield for you to dodge the attacks and Thor's hammer to absorb the damage in your stead is also necessary. Luckily for us, my boss did that for us. And what I can also suggest is best is to start multiple data science projects within the company that tackle different parts of the business, essentially allowing you to hedge your bets and help spread the word across the organization. At the same time, you'll have to work with execs to prioritize machine learning, figure out where does the change effort required to sit on the priority stack. Is it the highest priority for the business, or what else is it competing with? How do you increase the priority to get the required resources? You'll have to also define the value model. The business case comes from improvements in decision making, so creating the business case should come from a realistic estimate of the improvement, and ensuring that data is on the strategic agenda. Recognizing value of data in the written strategies of business, ensuring that it's recognized as a strategic tool. Teamwork is key as the next element. It seems quite obvious, but quite simply, data science teams that work in isolation will struggle to provide value. The key lesson is that data science team will need both data scientists and data engineers. Data scientists and data science and data scientists often get a lot of the limelight when in fact both data scientists and data engineers are vital to success for machine learning adoption. The data engineers are equally responsible for creating success. For us, having a great team of data engineers from the start who are experienced, resourceful, and extremely knowledgeable help to get those first successes faster. What I can suggest is that probably at the start of your data science journey within a company, both data scientists and data engineers have to be experienced, and both groups have to be able to struggle it out for some time until your first successes have been delivered. As a general tip as well, instead of waiting for a great team to work with, perhaps you could start by working towards becoming a good team player yourself first. And it's not just limited to teamwork within your team of data scientists and engineers. Teamwork alongside the right collaborators externally will do wonders. Finding the right people and team to collaborate with is key. Occasionally, you're going to have to learn to ward off people say no when they come asking to you for dashboards or analysis on their data, or killing the project, as we call it within the team. It's going to be a balancing act. And after you've had a few of your initial successes, you will have to be able to deliver consistently and to be able to handle a high volume of requests. Next is the communication strategy. Being able to communicate is the most important skill you can have to do this or any other job for that matter. If you're not able to communicate effectively at every level of company, you won't be able to make a career out of this job. Knowing that people are scared of new things and by what people don't understand, we evolved our comm strategy across the company. We bought company-wide awareness through a monthly knowledge sharing platform, or we call that as the Data Science Forum, writing blogs, giving a talk at a data science festival like this one, doing roadshows, providing regular updates through senior leadership, not just the progress against the strategy, but other topics of interest, deep dives perhaps into some of the use cases. And it's not just limited to the top execs, but also building awareness with the second tier leaders on the practical application of AI or machine learning through having some kind of show and tell, lunch sessions when we used to be in the office back then, but open house sessions, all of these things did definitely help. Next is the focus. What you need to focus on is problem solving, and the tools will come naturally. Don't fixate on a tool or a platform or deep learning. Some of the key questions that we ask at the start of any use case or engagement with a new business function are, what's the most important decision you're making in your area? How does this machine learning decision tie back to the company's or the team's wider objectives? Understand the decision points in the business. If you can move the decision by 1% in your favor, what would it be worth? This 1%, typically we look at it as 1% increase or decrease in whatever metric you want to improve. What does that translate to into monetary terms, if possible? And my personal favorite is what I call as the so what question, where we ask stakeholders, if you get a model that gave you the probability or the decision that you wanted, what would you do with it? How would you use it? This enables them to think about the processes or the actions that will be taken off the back of it. And also consider with them the end-to-end impact upfront. It can improve if we can improve this decision, what else needs to change to make it happen? Be it system integration, operational challenges, process impacts, or even the supplier model. You will need to find the right balance between automated decision making and what we can do with data. So I call that as like feet on the ground and head in the sky kind of thing, and manage expectations and prioritize. As you develop influence and build trust across the company, you can beat politics with politics. As I touched upon earlier in the previous section on the politics conundrum, the paradigm that you choose to respond politics with will depend on the work culture of the company, but most importantly, also on the social culture aspect as well. Local culture plays a big role in shaping the beliefs of how things work, how is power perceived by key people, Often in the Western world, it's more of a process or policy focus, whereas in other parts of the world, it may be a different approach. And even between the US and Europe, there's a difference on how things are done. So there's no clear best answer. You just have to play it by ear depending on where you are and what your circumstances are. Sometimes you'll also need to bring in outside help, even if it's frankly just for the optics, because some companies or heads off will trust things implicitly if it's repeated by one of those fancy suit wearing management consultants. And although this can be quite frustrating when you were emphasizing the exact same thing, occasionally it's the who and not what which matters. And although it shouldn't be the case, but that's how it is. And you need to think about it as a means to an end. Then finally coming on to the auxiliary skills, as I call. For any aspiring data scientists, you should definitely learn about data science. If you really like it, you have the patience, and you're ready for a steep and continuous learning and not afraid of failure. For all of the advice that I've imparted, the context matters. It's important to evaluate how well your personal goals and aspirations align with that of the environment that you're in. You'll need to find projects, companies whose goals are even best aligned to yours. So it may be okay to be choosy about a company when you have some experience under your belt, but when you're a fresh grad or someone transitioning from another career into data science, you may not have as many choices. So make the best one according to your judgment and personal situation. And remember, if you want to work on algorithms or work solely on deep learning, there's nothing wrong with that. You probably need to skill up and find a company that get hired there. Probably that's a deep mind, or probably you need to start one yourself. Such companies definitely may be a niche, but they're out there. And for the most part, in any mid to large commercial organization, you're going to face the challenges I covered earlier. So come prepared. Typically, there are many technical things you'll be expected to know as a data scientist, but I found that there are several other skills which are perhaps more important, like learning how to negotiate, probably even reading body language, problem solving skills, relationship building, defining scope, and I mentioned communication earlier. Funny enough, I can even recommend meditation. It will come in handy and help you keep calm in challenging situations and annoying stakeholders. Now, with skills such as body language or negotiation or working with difficult people, take your time. You're not going to know all of them instantly. These skills take time to master. Keep working on them and balance them out with other people in your team. Seldom will one person be good in all, so relax. It's okay to not know it all. You should enjoy the learning journey and take your time to learn things. And plan ahead and practice more deliberately. As with everything in life, none of these elements work by themselves. Over time, you'll have to keep building it up, keep adding momentum, and be at it. And at some point, it will be similar to the small stones or the pebbles that start an avalanche. So just kind of wrapping that bit up and moving on to give you guys some of the insights, other insights on how we look at the life cycle of a data science project and how we go about delivering one. We start with an initiation project where we make sure the use case is documented, forming a use case group, prioritizing it, assessing the business value, then jumping on to the build phase, which is sourcing data, building model, getting a sign-off, checklist, actually going on to implement it, some kind of user support, A/B testing, and then going live. And finally is the oversight element, which has governance committees, and they're a lot of fun. Benefit realization, some kind of model drift monitoring in place, probably looking at model refreshes. And these are just some of the things that make the magic of data science happen. So to succeed, you need a clear strategy that's enabled by technology. Machine learning, system integrations, automation, and digital interactions, all of these are individually powerful. But in combination, they are transformational. So the key point to take away is that there's no real need for a business case. All you need is things on the left side to add up to be greater than your resistance to change. And this kind of brings me to the last section on questions. And I leave that with a little bit of light humor. Thank you very much.
Thank you so much, Sandeep. That was a fantastic insight into the realities of being a data scientist in a big company like Liverpool Victoria General Insurance. There are loads of questions that have come up in the Slido, which is fantastic. So if it's okay, I'm going to move to that.
Should I stop scanning, Kate?
Sorry?
Should I stop
Yeah,
sharing?
why not? Why don't you unshare?
Okay, I've stopped it now.
Yeah, so if people want to flick their videos on, they can. So the first question then, I'm going to try and get through as many of these as we can. Okay, number one. What are the best and worst aspects of a data science career?
For me, I really enjoy working with a lot of different challenges, and where my role has changed is kind of probably slightly less from the hands-on element, which I must admit I do miss dearly, and now it's about a lot of stakeholders making strategy and making sure things are implemented, and it gives me a different element, so trying to balance it out. So I think like the variety of challenges is fairly big, and what I personally I enjoy is to learn things. So that's that gives me something which is yeah, it makes me excited about it. And I would be lying if I didn't mention this, is all of these things matter, make it much more better if you have a great team to work with. And so that for me is like the cherry on the cake. So having a great team to work with.
And so question on a similar kind of lines. What advice would you offer to a person without a PhD who's looking to be hired as a data scientist?
I mean, I don't have a PhD, so as I said earlier, it doesn't really matter. I mean, if you're open to learn, your journey may be a bit longer, as probably mine has been as well. And it's just sometimes the reality of the world we live in, where perception and reality are, don't often align. But if it doesn't work out for you at a place, just find something. I'm sure there's a place out there, and yeah, just keep at it and keep learning, keep applying, because yeah, I mean, as I said, having a PhD is great, but I don't think it's necessary. If you can think logically, have relationships, solve problems, and make sure things are done, that's all.
Yeah,
that's some of the things.
I would agree. In our Gene Golding Institute data science team, we have some people with PhDs and some people without, and they come with different skill sets. And
Yeah.
a similar question from Anonymous. As a master's in data science student, what top tip would you give for getting truly comfortable with data science? And the suggestion is maybe Kaggle competitions, that kind of thing. Yeah,
I touched upon that earlier. So I mean, like, I would say do Kaggle kind of stuff, but I don't think it's if you don't make it to the master or leaderboard, it's okay. I personally worked with a lot of charities, and I remember this instance from working with one of them, and I was standing next to their managing directors in the morning, and she just said, oh, we've gotten funding so we can pay you all for the next 6 months, and our problems on the field for saving the rhinos is something else. And I'm waiting there like, oh, when can I use to build a model for you? And so it just kind of was for me a wake-up call, and or it kind of woke me up to different realities, because often for them, this may not be a key bit. So you need to think about problem solving. So do as much as you can, but as long as you're enjoying it, it's fine. And then some questions about kind of the more day-to-day stuff within your work. So a question, how do you address unrealistic expectations of stakeholders who are not aware of the limitations of data science? Yeah, so I wish there was a straightforward answer to this. Sometimes it depends on it depends who are. You need to be patient. You need to be able to explain it. Most people do get it. Sometimes there'll always be special people who don't get it. So you then need to have, as I was talking about, the politics and the power balance. So if you, as a team, develop that balance, then you are, and as long as you're right, you're thinking it through, and you should be able to explain it why your reasoning is. Be considerate, understand what they're trying to do, but I would say is like, don't do machine learning just as a tick box exercise. I mean, you want to make sure that it's used, it's successful. Otherwise, reality is, as a Kaggle competition or whatever. I'm nothing against Kaggle, just FYI, but that will not match the reality. Is in at least most commercial organizations will have all of the challenges I covered.
And here's an interesting question. How common is collaboration between data scientists at different companies, e.g. developing generic tools or frameworks that can be used at individual companies?
So I mean, if you work in data science, like a lot of that is if we rely on open source technology. So I do imagine that in a lot of them, there is people wholeheartedly giving up their time, personal time to contribute to it. We've done that as well. We will be, as I said, on the roadmap for this year, at least have 3 packages. So that is people from our team contributing towards it. It's something personally I wanted to do as well, so I jumped in on one of them, and did a tiny bit, but it's just kind of, as a way to give back. So I think answering your question, I would say, like, generally, I mean, most open source tools, I mean, forget about the label as a data scientist contributing. I think if you're passionate, I think my title could be a janitor. I don't care for that, but what you're doing is more important.
Yeah, I agree. Another question, how big is the data science team in Bristol? Do you have University of Bristol interns working for LV2?
One of my colleagues is going to kill me because I don't know the answer for I think we're in Bristol specifically, I think 10 to 12. I could be wrong. This is somewhere about that. Interns, I think we are hiring interns, but we do have few success stories from Bristol. We have one of the guys who was a master's student, and he came for a thesis in our team for his master's thesis, and is now a part of the team. So we do have some things there. Overall, I think we are almost 40 now.
Yeah. I think that's about right. And I know that the kind of co-produced team within computer science has also hosted projects for master's students as well as part of their programs. So I know there's a lot of interaction between students and the data science team, even if not all of those are formal internships.
Yeah.
Okay, how about, what are the largest problems encountered when cleaning data in your experience?
I think not knowing what it is, as in like not having a data dictionary, or when was a reference point, things changed in the business, or often you will find that if something's been on for a while, they may have had many changes, or people who worked on them left, and that knowledge is kind of was in their head, kind of never documented. So I think that knowing what it is, I think that's the challenge. I think technically I wouldn't really say it's, I think most people, as you start working on things, I mean, whatever with Python or so, I think cleaning the data itself, I don't think that's such a big issue, as long as if you knew what it was about and what you were doing. And the other thing we do is we always try and reach out to the subject matter experts and ask them. And I think that helps to build relationships. So I don't really have, to be honest, apart from the data dictionary, for example. I think that's a real challenge, knowing what it is, where it came from, or source systems.
I agree. And kind of on a similar lines, someone's asking whether you can share more information on the open source LV packages and whether they're available